Hi, boys and girls. Today we are moving on to lesson 8 for math, and we're still talking about the commutative property of multiplication. So, if you have someone sitting around you, can you tell them what you remember about the commutative property of multiplication? And if not, you can pause the video and whisper to a pretend imaginary person what the commutative property of multiplication is. It's good to say it out loud. So either tell somebody or pause and tell the imaginary dragon sitting next to you. Okay, so if you come back to me now, do you remember that the commutative property is saying that we can take the two factors, the numbers that we multiply in a multiplication sentence, and just flip-flop them and the answer will still be the same? And do you remember yesterday? Actually, I have this sticky note from yesterday. We took the array that was 2 times 3, and then we just flipped it onto its side, and it became 3 times 2, but our answer was still 6. So it's the same array, we just turned it different ways, and our answer was still the same. So today we are continuing to use that commutative property of multiplication. So it says I can use the commutative property to solve problems. So that's what we're working on today. Okay. If we look next, it says commutative multiplying. And let's just label this array. So first of all, I'm going to put my array on shelves. So you need a piece of paper and a pencil or a whiteboard and a marker to work with me. So how many rows do we have here? 3 rows, right? We just put them on shelves. Remember, rows go this way. 1, 2, 3. Move your pencil or move your finger with me to show me the way rows go. Remember, 1, 2, 3. Rows go side to side like a bookshelf. Okay. And then how many is in each row? 5. And we can put the times sign in the corner. The first question says, how many groups of 5 do you see? Well, we already said that there's 1, 2, 3 rows or 3 groups of 5. And then it says to write 2 different multiplication sentences for the pictures. So the first one, let's write the way that we have been practicing, right? So the number of rows times the number in each row. So it would be 3 times 5 equals 15. Now we need to write another one. So using that commutative property, I can just flip-flop my numbers and my answer will be the same. But I can take my array and I can turn it onto its side. And now I have 1, 2, 3, 4, 5 rows of 3, right? 5 rows, 3 in each one. So all I'm doing is I'm switching up that 3 and 5 to now say 5 times 3, but my answer still equals 15. So that I love working with the commutative property because it's fun and it's pretty easy too. Okay, so looking at our next picture, we have hexagons, and it says, well, first of all, before we even look at that, let's label our array. So let's put these on shelves. 1, 2, 3 shelves. So how many rows do we have? We have 3 rows. And how many hexagons are in each? 4. I can put that time sign in the corner. How many groups of 4 do you see? We see 3. And pause your video, please, and write down for me 2 multiplication sentences that match this array. So 2 different multiplication sentences that match my array. And try to make sure the first one has the number of groups or rows first, okay? Okay, so if you're back with me, my first multiplication sentence is 3, because it's 3 rows, times 4, there's 4 in each row, and it equals 12. My second number sentence, so if I were to take that and turn it, I now have 4 rows, right? 1, 2, 3, 4, with 1, 2, 3 in each row. So it would now be 4 times 3. I just took those numbers and flip-flop them, and my answer still is 12. Easy peasy. All righty. So that was just a quick review today so we can jump in, not like yesterday. We did a lot of heavy reviewing yesterday to really make sure that we were solidified. It was the start of a week. It was the middle of a week, but it was a good review for us, okay? All right. So now let's go into the problem set. So I'm gonna give you a couple options here. So I don't think that there's anything on the front of this page that you could not do by yourself. So I strongly suggest completing the front of this page by yourself, and then you can unpause it and then go over it with me. Okay. If you still really feel like you need some support, you can watch it with me. But even if you feel like you're not sure, I want you to try something by yourself, because that's how we really learn, is by putting in that independent practice and really trying to stretch our brain. And being frustrated and having a hard time is not a bad thing, because that actually helps us to learn even more. If we're just whipping it off like that, we're actually not growing our brain. But if we're having a productive struggle trying to figure it out, that's actually how we learn, as long as we're trying. Okay. So give it a shot. If you feel good, do that whole front. But I want you to come back to me and at least do the first one, number 6, all parts of number 6 on the back. Okay. So if you want to pause it and go and then come back. So I want everyone to give it a go independently first. Make sure we're working. Okay. All right. So if you are back with me, the first one says draw an array to show 5 rows of 3. So we had 5 rows. I'm going to put the first 1, 2, 3, 4, 5. Put them on my bookshelves and put 3 in each one. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So then if you labeled it, which I hope you do label because I think it's helpful, you have those 5 rows of 3, and I can put my time sign there. Okay. And then number 2 said to draw an array that shows 3 rows of 5. So I'm going to put the first one in each row. 1, 2, 3, draw my shelves. Okay. So there's my 3 rows. Remember, rows go this way. Okay. And there's 5 in each one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I can label that one 3 rows with 5 in each one. So what did you think of that? What is that showing us? That's an example of the commutative property, right? So number 3 says to write multiplication expressions for the arrays in problems 1 and 2, and let the first factor in each expression represent the number of rows. Use the commutative property, which is what we said, to make sure the equation below is true. So problem 1, if we just take how we labeled it, we have 5 times 3 equals, so this is for problem number 2. So for problem number 2, we had 3 times 5, right? So 3 times 5. So here we had 5 times 3, which was right there. We flip-flopped it. We can turn the array, right? And that still gives us that 5 times 3. But looking at it this way, we have that 3 times 5. So they are the same, and it is a perfect example of the commutative property. Okay. For 4, this is just like what we did yesterday, right? We took this and we wrote some number sentences with it. So we have 3 2s, which is 3 times 2 equals 6, which is just like that. 3 4s, 3 times 4. Did you get 12? So really that's just counting by, if we have 3 4s, that would be counting 4, 8, 12, right? So for this one, 4 3s, that would be 4 times 3. I can count by 3s 4 times, 3, 6, 9, 12, or I know that it's 12 because I can use the commutative property right from there. 3 7s. Did you write down 3 times 7? Okay. And we can count by 7s 3 times. 3 7s is 7 plus 7 plus 7. 7 plus 7 is 14. And if you added 7 more, you probably got 21. Or if you feel better, 7 times 3 for this one, we can count by 3 7 times. And either way, that equals 21. And don't stress too much if you had a harder time with that skip counting. because we're going to be doing a lot of practice with that. We have songs that we're going to listen to for that. So 3 times 9 and 9 times 3. Either way you did it, if you counted by 9s 3 times or you counted by 3s 9 times, did you get 27? Okay, and 10 threes would be 10 times 3. So you could count by 3s 10 times, or the commutative property allows us to count by 10s 3 times as well, which I think is easier, don't you? So we have 10, 20, 30. So again, if you struggled with those, don't stress too much because we'll have practice there. Number 5 says to find the unknowns that make the equations true, then draw a line to match the related facts. So here we're counting by 3s. So we have count by 3s with me. 3, 6, 9, 12, 15. Here we had 3 times 9, and I actually had 3 times 9 up here, so I already know that that was 27. 7 threes plus 1 3. Well, 7 threes was here, and that was 21. I'm going to put that 21 right underneath there. Plus 1 3. Well, that's 3. So 21 plus 3 is 24. So if you were doing this part on your own and you struggled a little bit, that's okay. Just check this with me. This was a little bit new. Okay, 3 times 8. So that means that we can count by 3s 8 times or 8 3 times. So we have 3, 6, 9, 12, 15, 18, 21, 24. So that's a total of 24. This one has the blank right up front, but that's okay. So we have 5 times 3. So I love anything with a 5 in it because they're so easy to count by. So we can just count by 5s 3 times, right? So we have 5, 10, 15. So 15 right there. This one is trying to trick us maybe a little bit. So it says 27. So there's our answer up front equals 9 times blank. Well, if we look here, I know that 9 times 3 is 27. So 9 times 3. Okay. So again, if those were a little bit confusing to you, that's okay because this was new to you, but it's good to test it out. And if you got it, amazing. But don't forget to draw a line to match the related facts. Okay, so we want to match where they're related. So this was 3 plus 3 plus 3 plus 3 plus 3 equals 15. And right here we had 5 times 3 equals 15. Did you get that? Okay, and 3 times 9 equals 27. 27 equals 9 times 3. And here I had 7 threes plus 1 3 equals 24. Here I had 3 times 8 equals 24. And actually, this is actually saying 7 threes and 1 3 is saying 8 threes, right? So those are the same, plus they both equal 24. Okay, nice work, boys and girls. Okay, so when you're caught up there, go ahead and flip it over. Okay, so I asked you to wait for me to do number 6 if you had gone ahead, so I hope you're here with me, and we'll look at this one together. Isaac picks 3 tangerines from his tree every day for 7 days. Okay, so he picks 3 tangerines from his tree every day for 7 days. Okay, use circles to draw an array that represents the tangerines that Isaac picked. So he picks every day for 7 days, and I'm going to give you a little hint because we're going to have to add on to our array, so make it small. I wish they would say that. I might actually even stick it right up here so we have room. So since there's 7 days, he picks 3 tangerines for 7 days. 7 is going to be our groups, okay? So we're going to make 7 groups. I'm going to put the first one in each one, okay? So 1, 2, 3, 4, 5, 6, 7, okay? And I'll put my little shelves. And he picks 3 tangerines a day. So make sure that you have 3 in each group. Okay, so he picks for 7 days, and he picks 3 tangerines from his tree every day. So that's what we have so far. Okay, so A, we did that. It's right there. Okay, and if you need to pause it to get it caught up, that's fine. B says, how many tangerines does Isaac pick in 7 days? Write and solve a multiplication sentence to find the total. We have our sides labeled, so we can just take it, right? So 7 times what you put in the corner, 3 equals different ways that you could do it. You could count, you could touch every single circle and count. You could count by threes if you're good at counting by threes, and sevens if you're good at counting by sevens. You could go down like that. But any way you do it, that's your answer. Okay, so here's the next part of this. So I wanted you to make sure you save some room. So Isaac decided to pick 3 tangerines every day for 3 more days. Draw X's to show the new tangerines on the array in part A. So he picks 3 tangerines every day for 3 more days. So first of all, it was 7 days, and now he's got 3 more days, and we're using X's this time. 3 more days. So there's my X's to represent my 3 more groups, 3 more days, and it's still 3 tangerines every day. So we added in 3 more days. So draw X's to show the new tangerines on the array in part A. We did that. Write and solve a multiplication sentence to find the total number of tangerines that Isaac picks. And I'm actually going to change the color of my marker so that we can really see it good, what we're doing here. I'll use this blue Sharpie. Okay, so we started out with 7 groups of 3, and then he added on, he went for 3 more days he was picking tangerines, so he added on 3 more days of 3. So total now, how many groups do we have? We had 7 groups and 3. So total now, we have 10 groups. So will you scoop the side of this whole array that we made now and put a 10 there? Because that's the total number of rows that we have now. Okay, so we have 10 total rows, and there's still 3 in each one. So now that's our new multiplication sentence right there. Right? So we had 7 rows up top. We had 3 rows on the bottom. So we just say 7 plus 3 is 10. And I can do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 rows total with 3 in each one. Okay. So write and solve a multiplication sentence to find the total number of tangerines Isaac picks. There's 10 rows now, times 3 in each one. And there's a 10, so that's a friendly number to multiply, right? So I can do 10, 20, 30. So he picks 30 tangerines. What do we think? So we just have to look. It's not that hard if we just pay careful attention to directions there, okay? Because we're adding it on with the X's, okay? I am going to cross off number 7. If you would like to do number 7 and just include it in your picture, make sure that your teacher can see it really well. But you have worked super hard today, and I'm proud of your hard work, okay? So if you needed to pause it and look at that anymore, please feel free. And if we look back at our I can statement for today, I can use the commutative property to solve problems. Did we do that? We sure did, right? We definitely used that commutative property here, turning those arrays and finding our answers, seeing that they're the same. Here we use the commutative property to see that 3 times 4 was 12, 4 times 3 was 12, and so on. So it's definitely a handy property to have. So nice job today, boys and girls, and I will see you tomorrow.